So, so time scaling means time scaling means that the operation is related to the change in the time scale of the signal. Time scale means the in the time axis. Okay. So there are two type of scaling operation is there. One is downsampling, which is also called compression, and upscaling, that is called expansion of the system. Let's see one by one what is the compression and what is the expansion of a signal. So we are discussing with a signal. The signal is represented by this way. Xn in is sample values are 1, 2, 3, 4, 5, and the origin lies and the first sample. Now this signal is Xm. Let a signal X2n in time axis. A multiplication is there with a integer 2. Let's see what is happening after multiply a multiplication with these two. So we know that this is the first sample 1, 2 is the second sample, 3 is the third sample, 4 is the fourth sample, 5 is the fifth sample. We can designate each and every sample by this way. X0 is 1, x1 is 2, x1 means the sample value at position n equal to 2, n equal to 1 is the value 2. At time instant n equal to 2, that means this, the sample value is 3. This way we can write or designate, uh, we can write for every sample value with some suitable indications, that is x1, x0, x1, x2, x3, x4 and x5. Now let's see, if we multiply if with this n to 2, it is 2n. Now let's see what is this. So first we are putting n equal to 0. So yn is x equal x in bracket 2n. So first we putting 1 equal to n equal to 0. So this is right hand side, this is y0. Now we are just plotting the output of the operation. So y0 means in the vertical axis we are considering yn, and in the horizontal axis we are considering n. So y0 obviously it will be at n equal to 0, what will be the sample value we are finding out. So according to the equation yn equal to x2n. So if we put n equal to 0, it will be y0 equal to x0, and which is from the earlier representation x0 is 1. So x0 is 1. So we got y0 which is 1 sample value. Now to get the second sample value we are considering n equal to 1. So y1, so that will give me the sample which will be at n equal to 1 at position. So n equal to 1, so it is 2. So what is the value in x2? x2 value is 3. So here I am writing 3. So y1 is, therefore y1 is 3. So y1 is 3. Next in the n equal to, we are putting n equal to, we are considering n equal to 2. So y2. So y2 will be 2 into 2, that is x4. x4 sample value is 5. So this is 5. So y2 sample value is 5. Now To get the next sample value, we are putting n equal to 3. That is y3. Y3 is basically x equal to into x in bracket 6. So here you the last sample we are getting for n x equal to 5. Thereafter there is no sample value is there according to the equation signal we have taken. So obviously x6 will be 0 and rest other values will be 0 if we change the value n. So the output signal we can represent 1, then 3, then 5, then 0. Now after that operation we got this signal. Before the operation the signal is this 1, 2, 3, 4. Okay, 1, 2, 3, 4. Now you see that number of sample values is here 1, 2, 3, 4, 5. 5 sample values are there. But after this type of operation, we observe that the sample value is get decreased 5 to 3. So this is called downscaling and is compression, that means number of sample value reduced. So this is called compression. Now let's see what will happen if we consider yn equal to x n by 2. In the first case we just multiplied with n by with 2. Here we are dividing n by 2. Let's see how the signal nature now changes, which way it will change. So we are doing the same thing. We are considering the signal x n equal to 1, 2, 3, 4, 5. Now we are putting same rule we are following. We are considering from n equal to 0, 1, 2, 3, 4 this way. So n equal to, if it is 0, then y0, and here also in the right hand side we are same time we are plotting after getting the sample values. So this is axis is a, this axis is yn. So when n equal to 0, y0, so it will be x0 by 2, that is x0, which is according to the equation 1. So 1. Now if n equal to 1, then y1 x 1 by 2. So here in this equation you see this sample value is for n equal to 0, this sample value for n equal to 1, but there is no sample value for n equal to half. So there is no sample value means 0, no sample value. So no sample value, we just wrote no sample value. Now n equal to 2, when n equal to 2, according to the equation y, so here also we see that we skip n equal to 1 because we didn't get any sample value here. So n equal to, if it is 2, then y2 x 2 by 2, which is x1, and according to the equation it is 2. Next, when if we consider n equal to 3, we got x 1.5, and in that x 1.5 there is no sample value at all. So there is no sample value. This way, if we do these calculations, we got that at n equal to 0 we are getting sample value 1, n equal to 2 we are getting sample value 2, n equal to 4 we are getting sample value 3, n equal to 6 we are getting sample value 4, n equal to 8 we are getting sample value 5. That means the even integers we are getting sample values. But in between the odd numbers we are not getting anything. Now we see that here earlier the time scale is 0, 1, 2, 3, 4. Now how much time scale is there? 0 to 8. That means in time scale the signal get expanded. Here in the previous case is that the time scale get reduced. Time scale is 0 to 5, 0, 1, 2, 3, 4, 5. Sorry, 0, 1, 2, 3, 4. Length is 5. So here you see that in time axis it is get squeezed, but here in time axis the signal get expanded. For that reason, this operation is called scaling up, upscale. Sorry, this operation is called expansion, which is also called upscale. So now we little bit got the feelings that what is data expansion, data compression. If we consider in terms of data, which we are more familiar, compression, expansion. Compression term maybe many you have heard. It is used. It is this type of algorithm is used to compress data, to send data one place to another, so that less number of resources being used while transmission. So you know the data compression, which is a very simpler form of this data compression. So now, so very important operation we have studied, scaling up and scaling down. It is little bit, you see, it little bit tricky. If n is multiplied with integer value 1, 2, 3, 4, then the signal get compressed. If n is divided by some value 1, 2, 3, 4, 5, 6, then the signal get expanded. So division in bracket the time scale n if is we divide something, signal get expanded. If we multiply something, signal get compressed. This is a very tricky formula, but it is little bit ambiguity is there. So you should have to remember and clearly understand. This one is very important operation on signal. Next operation is very simple. This is amplitude scaling. Scaling. This is called amplitude scaling operation. So very simple this one. If xn is this, if the signal is multiplied with 2, xn is multiplied with 2, then all the sample values which are there inside the bracket will be multiplied by 2. Each and every sample value will be multiplied by 2. Now what will be the strength of the signal sample value will be increased twice. So 2, 4, 6, 8, 10. So this is very simple one. Now attenuation or downscaling. So here obviously what we are doing, we are dividing the signal by some value. Here in this case it is 2. So the sample value get halved. So the sample value obviously will get half. So we are getting the sample values 0.51, 1.52, 2.5 like this way. So amplitude get reduced. That means attenuated. Amplitude is attenuated or downscaling. Addition. If x1 is this signal 1, 1, 0, 1, 1. If x2 is this signal, if we add the signal, then what will happen? Let's see. So 0 is there. So 0. This is 1, 1. This is 1, 1 sample value. This is 0 is there. So this 0 is there. This is sample value is 2. Sample value is 2, 2, 2. We have to add the signal such a way that the sample value, actually I am trying to say that the sample value which is in the same position we have to add. 0th sample value will be add together, can be add together only. 1th sample value we can add, 2nd sample value we can add. Like this way, consecuting position of the time, whatever the strength of the signals are there, that will be add. So in this way, this is 1 plus 2, that is 3, 3. 1 plus 2 is 3, 3. So the sample values will be, if the consecutive sample values get added, the signal will be like this. Next operation, obviously multiplication. Again, we are drawing the signal and the consecutive sample values will be getting multiplied. So 1 into 2 is 2, 0 into 0 is 0, 1 into 2 is 2. Here in this side, left hand side, 1 into 2, 2, 1 into 2, 2. Now let's see some operation of the signal. Suppose we have this discrete signal 1, 1, 1, 1, 2 and origin lies here. Now if we perform this kind of operation, let's see how the signal will looks like. So xn minus 2 will be, obviously we have studied this operation. This operation is called delayed operation. Delay operation. So delay operation means that if the signal is situated here, the signal get advanced, signal gets signal get delayed by 2 units. So signal is starting from minus 1. Now it will start from after delay 2 unit second, that is from 1. Signal is starting. So this is delay. Next n plus 1 we have also studied this. This is called advance. So signal was starting from n equal to minus 1. Now it is starting ahead of that, 1 second ahead. It is starting from minus 2 at position. Now next operation is x3 minus n. So x3 minus, to get the signal x3 minus n, what we have to do? First we have to find out what is the signal of x equal to x minus n. Then we will do some uh, delay or advancement, whatever is there. We will do that and we will find out what will be the signal. So now xn is this, x minus n will be, we have already studied this property, it is called mirror image. So if we consider in the y-axis there is a mirror, then this sample value will be shifted to left hand side and this sample value will be shifted to the right hand side, but the sample value which is in the 0th position, it will be unaltered as the mirror image is looks like this. So at the 0th position, the sample value will not change, it will be there only. So now x n minus 3 minus n can be written x minus n plus 3. And plus 3 means anything plus will be advancement, not delay, advancement. So signal, sorry, I am very sorry. So um, so actually actually the signal will be delayed. So here 0th position is there, here is the 0th position and signal get delayed by 3 unit. So now 0th position will be 0, 1, 2, 3. So here this position, 0th position, 0th sample value will be there. So signal will be shifted to the right hand side by unit 3. So if 3 is shifted, so then minus 3 sample value will be at 0th position sample value. So signal will look like this. So we can get this signal like this way: x3 minus x minus n x minus n minus 3. We can do by this way also. So x minus n, that will be more easier to understand, I think. So this is the xn. X minus 3 means sorry, I am making it confusing. So this is the I should do, because the signal folding is done only for n, not constant value can we can't attach with that. So this only operation will be considered for only n for n value only. So as the n value is minus n, so we can consider the whole value. So this is the correct representation of the signal x minus n plus 3. Now, last day also we discussed that any signal is multiplied with unit impulse, then what will happen we know. So this is the signal 1, 2, 3, 4. This is the representation, and un is this. We have no unit impulse and unit step signal. So this is of unit amplitude, and if we
ये तो ऑफिसर्स क्लब में है या तो आई
mm,
थिंक ये पे
delay the signal by 1 unit according to
यार
the
मैं सुना हूँ
equation,
बहुत
so
हॉस्पिटल
it
के
will be
साइड में
like
है
this 1 1 1
हॉस्पिटल
1.
में
Now if we
वहीं सब रोड
multiply
में
these two signal,
देख ले
we will see that the one will multiply it with one for the signal we will get from 1th position, because n equal to 0, n equal to minus 1, as the amplitudes sample values are 0, ultimately after multiplication we will get 0 there only. So the signal will be like this. So signal will be like this. So you see that here, after multiplication, what we have seen, we are making the signal a causal one. Causal one means here in this case, all the sample values of the signal are lies only on the positive n values, positive indices of n value. There are no sample values are there in for the negative ends of negative values of the n. So this is operation is very significant. To make any signal causal, we have to multiply it with a unit step signal, because the amplitude is 1, and in the negative axis, as there is no value for the signal, if any values are present, that will be nullified. Now unit impulse. Unit impulse we know very well. Unit impulse, if it is u delta n, and the sample value will be there for n equal to 0. If it is delayed by 1 unit, sample value will be at 1th position, but for rest values, whether it is negative or positive, the sample values will be 0 only. So if this type of signal is getting multiplied with the any signal, so what will happen? At 1th position, we will get the sample value, but rest any sample values, uh, whatever is present for the signal will be nullified. So only at a particular sample value will be selected. Now you see that if we shift the signal another 1 unit, suppose the say a step impulse is now at n equal to 2th position. So what will happen? The 2th position will be extracted only, but all other sample values will be 0. This operation is very useful while sampling. We will perform sampling of the signal. Suppose we have uh, um, many marbles are there. We are picking only one marble. That means we are sampling from many to one. That is called sampling. Here you see that in the signal, many sample values are there, but we are picking only one. That's why of multiplication with the delta signal is also called sampling of the signal. This operation is very useful and it will be applied in the various places. So, so this is the this is the odd sample and even sample. So we know that x2n is a event sample signal. That means all sample values will be uh, 2, 4, 6 this way. So here in this case sample value is 1, 0, 1, 0. That is no sample values are 4. So if 2n is the even number, if we added 1 here, it will be odd number. So that means when n equal to 1, it will be 3. So that this type of signal is odd sample signal. Now discrete time system. So we have completed our discussion on signal. Now from onwards we are just uh, we are coming in the field to discuss the systems. Now what is system? Suppose we consider system a black box. So that means it will take some input to give some output. This is the exact operation of the system. It will take some input, it will produce some output. In other way, we can also say that system is basically an interface between input and output. That means it is an interface between input and output. If we do the formal definition of the system, then we can consider the definition will be like this. A discrete time system is a physical device or an algorithm, because we know that as we are coming to digital signal processing domain, digital domain, everything can be programmed. So in bracket it is written algorithm. That means the system can be developed by program also, software program also. This is the biggest advantage, because if it is a software program, then anytime we can alter the system, we can change the performance of the system, characteristics of the system. Anytime we can improve the system. So this is the flexibility, as this type of system can be built using software program. So a discrete system is a physical device or an algorithm which performs required operation on a discrete time signal. Required operation means what user intended to do. Required operation depends on the user. What user will define the software, which way the system will perform like this. So the input we are always designated by xn and output is designated by yn. So it processes the signal. Actually, we can also say the we are discussing digital signal processing. The name of the system will be discrete time system. It will take the input signal and it process the input signal and it produce the output signal. So input signal is also called excitation. Output signal is also called response of the system, and the operation of the system is called processing. So system process the input signal to produce response. This way we can also define. Now, how the mathematical way we can define in our course, how this processing kind of thing we can uh, define by mathematical equation. Xn is a signal. When it passes through a system, system transform the signal to produce output. So this T represent transformation. System will produce the signal which is transformed by it. So system transform the input signal to produce output. Or this equation also can be represented by yn equal to T of transformed of input signal. So here T is called as transformation operation. What kind of transformation it can do? Many transformation we can do. One transformation we can provide an example like a filter. We know we have understand we have heard the term filter. Filter is basically a frequency selective network. Frequency selective network, that means its performance depends on the signal frequency. So that means it will allow to pass certain frequency signal, and it will block some certain frequency signal, it will block. So this is the operation of filter. So we can the system we can consider filter is a system. It will take some signal, it will alter its frequency. It will allow to pass some frequency of component of this input signal, and it will attenuate some frequency of the input signal. So this is called a system filter. The symbol used to represent a discrete
हाँ
system. At the beginning of this
हाँ दो फ्राइड चिकन मोमोज
very
और
beginning of the
एक
class,
चिकन
I
लेग
said
पीस
that the digital
लेग
system is
पीस
easily
लेग पीस
implementable.
चिकन लेग पीस
Some little,
कोकोड़ा लेग
some
पीस लेग पीस
a
टंगड़ी है
finite
टंगड़ी
number of components are there by which
हाँ
we can represent. We can produce any kind of
और कुछ
operation. That first
और
operation,
कुछ
first is adder. That means addition. Second is constant multiplier. So here you see that if the signal is xn is a signal, x2 is a signal, it can add the signal to produce x n1 plus n2. Or we can xn is a say x1 signal, we can subtract two signal also. Constant multiplier. This is called adder block. Adder subtractor. So constant multiplier, xn is the signal, it is multiplied with the constant factor yn equal to a into xn, where a is the constant number. So individual sample value will be multiplied with the constant a. Signal multiplier, xn is a signal, x2 is a signal. We can multiply these two signal to produce x1 into x2. Unit delay. Unit delay is represented by this symbol. It may be mu to u. Xn is a signal, and if there is 1 unit delay, it is written z to the power minus 1, and the signal will be xn minus 1 delayed signal. If the signal get advance, then it is written z only. So 1 unit advance. Xn advance 1 unit means xn plus 2. Now, if xn is a signal, it is get delayed by 1 unit, then the signal will be xn minus 1. Then the signal is further delayed by 1 unit, then the signal will be xn minus 2. Now, interconnection of the discrete signal. System. So one is cascade. Cascade is this. It is connected in series interconnection, parallel interconnection, and feedback interconnection. This is series combination. Two systems are placed in a series, two systems are placed in a parallel position, and this is feedback. Feedback means some portion of the output is taken as an input to the second system. So this is called feedback. So this is one system, this is another system, they are connected in series. So if xn is the input, the first block output will be yn, which is transform of the x1. So this is the first system. That's why to differentiate, we are putting one in suffix, so that it can designate the operation which is happening for the first block. So transformed of the input signal xn. Then again there will be another transformation because the second system is there, which is present in series. So transformed for the second system for the signal yn minus y1n. Y1n is the output of the first block. So yn from the one previous block we can write transformation of input xn. So here it is more transformation of input transformation of t1 into x1n. So this is, there is two transformation. There is two transformation. So double transformation is happening for this kind of arrangement. Now in the parallel interconnection, first xn is coming, it is transformed to produce y1n. Is it is transformed by the second system to produce y2n. These two signals get added, and this signal after adding, the signal is yn y1n plus y12. Now for the feedback system is very interesting system. Here feedback means some portion of the output signal is taken to the input side. This is called feedback, and feedback is positive feedback as negative feedback. Two type of feedback is available. Whether the output signal, sampled output signal is added with the first input sample, then it is called positive feedback, and if it is subtracted from the input signal, then it will be called subtractor. Sorry, it will be called a negative feedback. Now, if xn is the signal, the output of this block will be transform of xn. Then some portion of the signal is coming here, and the signal is being feedback. Sorry, the signal is being transformed by this system, and it will give t2yn. So yn is this. So it will be like xn transformation of yn. So this is xn according to the equation. This is xn, yn will be xn, and transformation of yn. Yn signal is coming as a feedback, and it is transformed by t2. This is transformed by t2. So output will be, what will be the output? This for contribution will be for this block as well as this block. Here in this block, input signal is xn, and xn plus this is the input signal to the system. This in this block y2 yn, y2 yn, and in the full bracket transformation is happening for the this main branch. So we are coming this type of equation. So this is summarization. This is adder, this is constant multiplier, this is signal multiplier, this is unit delay, this is unit advance. Now again, properties of the system. Properties of the systems
to
are
have force voltage
discrete,
analogy. So
whether
let
it
us
is
do
dynamic,
mathematical modeling
static,
first.
time variant,
So
linearity,
to have
causality,
mathematical modeling of
stability. These
system,
are the properties of the
there are few
system.
basic steps which we need to follow. First step is to identify
Now the
number of nodes
classification of the
and
system. The
number of nodes is equal
classification of
to
the system signal is classified these categories
Hmm,
with
bro.
static, dynamic, time variant, time invariant, linear,
Hmm?
non-linear,
बोल बोल
causal, non-causal, stable or unstable.
जिसको बंद है
So we will, as it will take much more time,
आज ही जल्दी
we will
है
be discussing this
आज ही जल्दी बता दीजिए
system classification in the next class. Okay. Anyone have in doubt?
स्कूल के अंदर था शायद एक
Any query?
नहीं
So,
स्कूल के अंदर नहीं कैसे नहीं होता है ये
so let's
हॉस्पिटल कौन सा था
today's
साइबर
take today's attendance.
हॉस्पिटल अंदर जा ठीक है चुपचाप जाना चलेगा एक बार चलना पड़ेगा अच्छा रुक पहले मैं थोड़ा किसी से बात कर लेता हूँ देखता हूँ अगर किसी को पता है फिर उसका अगर पहले मैं किसी किसी से बात करके देखता हूँ कि रोज़ कहाँ मिलता है पूछ के देखता हूँ ठीक है फिर जा जाता हूँ ठीक हाँ आ जा घर के बाहर आ जा मैं निकलता हूँ
First, Anindita,
displacement. Now, if you observe in the system, force F is applied over here.
Present, sir.
Anindita,
Present, sir.
please tell me your roll number.
Sir, 079.
Okay, thank you. Uh, Ankit,
Present, sir. Sir, 047.
please. Okay. Okay, Jesus. Arnav,